Good day, everyone. My name is Vince Calvary Vistir. I'm a first-year electrical engineering student from Central Philippine University. I am here to teach you three topics of integral calculus. The first is basic integration. Second is the general integration and U substitution. And the third is the integration by parts. First is basic integration. Integration is the reverse of differentiation. I here symbolizes integration, and we're going to solve the integral of the function f of x dx. There are four functions that we're going to solve in basic integration. First is the algebraic function, second is the exponential function, third is the logarithmic function, and fourth is the trigonometric function. There are two types of integral. The first is the differential. The formula is the integral of f of x dx with the limits of from a to b. Next is the integral, and the formula is the integral of the function of f of x dx. Basic integration formulas for algebraic functions. We need to remind and remember all of these formulas and rules in solving algebraic functions. First is the integral of 0 dx. The integral of 0 is equals to 0 and change dx to the constant c. So 0 plus c is equals to c. Next, the integral of the integral of a dx. Put out a and integrate dx equals to a, copy, and the integral of dx is equals to x and add the constant c. Next is the integral of ax dx equals to put out a as the constant and integrate x dx, which is equals to copy a, the integral of x is equals to x squared over 2 and add the constant c. Why x squared over 2? The exponent of x is equals to 1, and if we integrate, we are just going to add 1. So 1 plus 1 is equals to 2. So x integrated into x squared dx, and the exponent is also the denominator. Next is the integral of ax squared dx. Again, put out a and solve for the integral of x squared dx. And it is equals to copy a, the integral of x squared is equals to x cubed over 3. Again, we're just going to add 1 to the exponent and copy it as the denominator and add the constant c. So the answer is ax cubed over 3 plus c. Next is the integral of a x raised to n dx. Again, put out a and integrate x raised to n dx equals to a, copy it, x raised to n, the integral of it is x raised to n plus 1 over n plus 1. Why n plus 1? Because if we are going to integrate, we're just going to add 1 to the exponent and copy it as the denominator and add the constant c to your final answer. Next is the basic integration formulas for trigonometric functions. If we had rules and formulas for algebraic functions, there are also rules and formulas for trigonometric functions. First is the integral of sine x dx. The integral of it is equals to negative cosine x plus c. Next is the integral of cosine x dx is equals to sine x plus c. Next is the integral of tan x dx, which is equals to the ln of secant x plus c. Next is the integral of secant x dx, which is equals to the ln of tan x plus secant x plus c. Next is the integral of cosine x dx, which is equals to the ln of cosecant x minus cotangent x plus c, or the ln of tangent x over 2 plus c, because cosecant x minus cotangent x is equals to tangent x over 2. So the answer is ln of tangent x over 2 plus c. Next is the integral of cotangent x dx, which is equals to the ln of sine x plus c. Next is the integral of secant squared x dx, and it is equals to tangent x plus c. Next is the integral of cosecant squared x dx, and it is equals to negative cotangent x plus c. Basic integration formulas for exponential functions. Exponential functions are those of the form f of x is equals to c times e raised to x, as c is the constant, and the linear shifts and inverses and quotient of such functions. Exponential functions occur frequently in physical sciences, so it can be very helpful to be able to integrate them. Nearly all of these integrals come down to the two basic formulas. The first one is the integral of ex dx, which is equals to ex plus c. The next formula, the integral of ax dx, which is equals to ln of a times ax plus c. Next, the basic integration formulas for logarithmic functions. First, we are going to recall the power rule for integrals. If n is equal to -1, we cannot solve the problem because it would force us to divide by 0. So what we're going to do is we're going to solve and recall the fundamental theorem of calculus, which is equals to the integral of 1x dx times 1x times the integral of 1x dx, and it is the antiderivative of 1x. So we can conclude that the formula for logarithmic function is the integral of x raised to n dx is equals to x raised to n plus 1 over n plus 1 plus c, and n is not equal to 1. So later, we are going to solve 4 functions and sample problems for basic integration of algebraic, trigonometric, exponential, and logarithmic functions. I have a recorded video of me solving these 4 problems, and I will show it later. Next topic is the general integration formulas and U substitution. So what is U substitution? U substitution is also called the integration by substitution or the reverse chain rule. It is a method to find an integral, but only when it can be set up in a special way. The first most vital step to be able to write the integral in this form is that the integral of f of gx times g prime of x dx. Note that we have gx and is the derivative of g prime of x. Example, the integral of cosine x squared to x dx. So f is equals to cosine and g is equals to x squared, and the derivative of x squared is equals to 2x. We can use substitution like this. The integral of f of gx times gx prime dx. So we're going to substitute gx to u and g prime of x to du. And if we solve the problem, we can put the value of u back to gx. I have two sample problems that I will show you, that I'm going to show everyone later. So we're going to solve the integral of cosine x over sine raised to 7x dx. So here's the formula. This is how you substitute, and this is the answer. I will show you later the video. Next, integration by parts. Integration by parts is a special method of integration that is often useful when two functions are multiplied together, but it's also helpful in other ways. Integration by parts work when new integrand contains a function multiplied by the derivative of a function. The rule in solving the integration by parts. So here it is. The integral of uv dx. U symbolizes the function of u, and u prime is the derivative of the function ux. So this is the formula. U, put out u as the constant, and integrate v dx minus the integral of u prime times the integral of v dx. So this is the rule and the formula in using the integration by parts method. Here is the rule in diagram form. So again, I have a video of me solving two problems of integration by parts. We use this formula, and the problem that we're going to solve are the integral of x squared ln of x dx and the integral of x squared sine x dx using integration by parts. So we're going to watch first the basic integration video. So here it is. We're going to solve the first problem, the integral of e sine x over secant x dx. So we're going to use substitute sine x and the derivative of sine x, as we all know, which is cosine x, and dx is equals to du over cosine x. I'm sorry about the YouTube video. I'm just going to explain it here, and I will adjust and post again another YouTube video so that it will be clear. So first is the integral of e raised to sine x over secant x dx. We're going to substitute sine x in the derivative of u, which is the derivative of sine x is equals to cosine x dx, and dx is equals to du over cosine x. So let's integrate. The integral of e sine x cosine x dx is equals to the integral of e, substitute sine x to u, and substitute cosine x to du. The integral of eu du is equals to eu, and substitute back u to sine x. So the answer is equals to e sine of e raised to sine x plus c. It is an example of an exponential function. Number 2, the integral of ex sine e raised to x dx. Again, we're going to use u substitution. U is equals to e raised to x. The derivative of u, which is e raised to x, is the same, and dx is equals to du over e raised to x. So let's integrate. The integral of sine u, because we are going to substitute e raised to x to u, and du. So the integral of sine u is equals to negative cosine u plus c, and is equals to negative cosine, substitute back e raised to x, plus add the constant c, and that is our final answer. Next, number 3, the integral of 1 over the quantity of 1 plus x arctan x dx. Using u substitution, u is equals to arctan x, and the derivative of arctan x is equals to 1 over x squared plus 1 dx. And dx is equals to 1 over x squared plus 1 du. So let's integrate. The integral of 1 plus x over 1 plus x, u substitute arctan x and du. Cancel. So the integral of 1 over u du. 1 over u is equals to the logarithm of u plus c. Substitute back u to arctan x. So equals to log of arctan, oh I forgot the x, sorry. But the answer is the log of arctan x plus c. Next, number 4. The integral of 4 over 9e raised to 2x plus 3 dx. U is equals to 3 e raised to 2x plus 1. We're just going to factor out this. So du is equals to 6e raised to 2x dx. And dx is equals to e raised to negative 2 over 6. Now we solve. The integral of, put out 4 and times 1 over 9e raised to 2x plus 3 dx. So the constant 4 will be put out, and the 1/3, which is this one, will be put out also. we're going to factor out 9e 2x plus 3. So equals to 4 times 1/3 times the integral of 1 over 3e raised to 2x plus 1 dx. Combine. So 4 times 1/3 is equals to 4/3. And the integral of 3e raised to 2x plus 1 is 1/2 over u plus u minus 1. So 4/3 times 1/2 times the integral of negative 1 over u plus 1 over u minus 1 du. Combine. 4/3 times 1/2 is equals to 2/3 because cross multiply. Just going to cross multiply it or multiply it this way. So 2/3 times the quantity of negative ln u plus ln u minus 1 plus c. Substitute back u. So 2/3 times ln 3 plus 2x minus ln of 3e raised to 2x plus 1 plus add the constant c. And that's our final answer. Next. U substitution. During our basic integration, we use U substitution in solving the 4 problems. So now we're going to do it again. So we're going to solve the integral of cosine x over sine raised to 7x dx. We're going to substitute sine x to u, and the derivative of sine x is equals to cosine x, and dx is equals to 1 over cosine x du. Equals to the integral of cosine x over u raised to 7 times du over cosine x. This is dx, by the way. So cancel out cosine x. Equals to the integral of 1 over u raised to 7 du. And we're going to put u raised to 7 up. So the reciprocal of it is u raised to negative 7 du. Then integrate. Equals to the negative of u raised to negative 6 because u plus negative 7, and we're going to integrate it. So we are just going to add 1 and copy it to the denominator. So u negative u raised to negative 6 over 6, which is equals to negative of 1 over 6 u raised to 6. Just put it back to the denominator. Then substitute back. The answer is negative of 1 over 6 of sine 6 raised to x plus c. Number 2, the integral of x cubed cosine of x raised to 4 plus 2 dx. Using u substitution, u equals to x raised to 4 plus 2, and the integral of x raised to 4 plus 2 is equals to 4x cubed dx, and dx is equals to 1 over 4x cubed du. Now we are going to integrate. So the integral of x cubed, substitute x4 raised to x raised to 4 plus 2 to u. So cosine u times 1 over 4x cubed du equals to the integral of 1/4 times cosine u du. Put out the constant 1/4 times, then integrate cosine u du. So equals to 1/4 integral of sine. The integral of cosine is sine, and substitute back x raised to 4 plus 2 and add the constant c. Next, we're going to solve integration by parts. The first problem, the integral of x squared ln x dx. We're going to use u substitution also. U is equals to ln x and the derivative of u, which is equals to 1 over x dx. And dv is equals to x squared dx and b is equals to x cubed over 3. Using this formula, the integral of u times v dx is equals to u times the integral of b dx minus the integral of u prime times integral of b dx. So, the integral of u, which is ln x, is equals to v dx. So, v is equals to x cubed, so ln x times x cubed minus u prime, the integral of x cubed over 3 times 1 over x dx. So ln x times x cubed over 3 minus 1 over 3 times the integral of x squared dx. So equals to ln x minus x cubed over 3 minus 1/3 times the integral of x squared is equals to x cubed over 3 dx, and we're just going to express it more. Equals to x cubed over 3 times the ln x of negative x cubed combine x cubed over 3 minus negative 1/3 is equals to negative x cubed over 9 plus the constant c. Next problem. The integral of x squared sine x dx. So using u substitution and integration by parts, u is equals to x squared, du is equals to 2x dx, dv is equals to sine x, and the derivative of sine x equals to v is equals to negative cosine x. Using the formula of integration by parts, so we're going to solve x squared times negative cosine x, which is the u v dx, u the integral of v dx, minus the u prime negative cosine x times 2x dx. So equals to x squared minus cosine x. We're going to distribute the negative sign. So we're going to change to positive, put out the constant 2, and factor out. The integral of negative cosine x is equals to x sine x minus in the integral of sine x dx. So copy this one, x squared times negative cosine x plus 2 times x sine x minus the integral of sine x, which is negative cosine x plus c. Now multiply this one, the first term, equals to negative x squared cosine x plus 2, and also multiply this one, distribute it, plus 2x sine x plus 2 cosine x plus c. This is your final answer. These are the links on how to solve the sample problems, but I will post again for the basic integration because it is a bit blurry, and I hope you will watch it and enjoy. Thank you for listening. I hope you enjoyed and learned, and next time we will solve more problems, and God bless everyone.